back. This is Mr. Hassan's Maths channel. I've now reached question number 5 from the June 2023 Statistics S1 paper from Edexcel International A-Level. And here we have a question about discrete random variables. And they've told us that the discrete random variable y has probability function. And here this says the probability that y is equal to y. So the probability that the discrete random variable y is equal to these particular values, which are 1, 2, 3, 4, 5, and 6, are given by these expressions here. Okay, so for us to really get a proper understanding of what this actually means, what I'm going to do is I'm going to convert this into a probability distribution table. Okay, so I'm going to have this table that I prepared earlier, and I'm going to put this down here. Okay, and then we will fill this table in with the information. So basically, this discrete random variable y has a certain number of possible outcomes. So the discrete random variable, which is called y, okay, can be 1, or it can be 2, it can be 3, 4, 5, or 6. These are the possible kind of outcomes of this experiment. So a discrete random variable is the result of some sort of an experiment, okay, and the outcomes of that experiment should always be numerical if it's a discrete random variable. So, for example, throwing a coin and saying, is it going to be heads or tails? Well, heads and tails are not discrete random variables because it doesn't have a numerical value attached to it. But if you say, I'm going to throw a coin 5 times, and the discrete random variable is defined as the number of times a head appears when I throw the coin. So it could be 0 times that a head appears, or 1 time, or 2 times, or 3 times, or 4 times, or 5 times. So those would be the discrete random variables for that description of that particular situation. Here we don't know what the actual, real situation is. It's just we're given some numbers here. So we know that there's a discrete random variable, okay, which has these 6 outcomes. So it could be, for example, if we want to put some, kind of like a real life kind of understanding to it, we could say, let's imagine that there's a dice which is not a fair dice, and these are all the possible outcomes that could take place when you throw the dice. When you throw the dice once, you can either land on a 1 or 2 or 3, 4, 5, or 6. Those could be the numbers that show up. So we want to find the probability of each of these. Now, if each of these has different probabilities, it's not like a fair dice, it's not a uniform distribution. So we have to find the probability that y is equal to each of these particular outcomes. The discrete random variable is equal to each of these particular outcomes. In fact, that should say a small y here, as far as I remember. Okay, so we're going to now find the probability of each of these outcomes in terms of k first. So we can see here that when y is equal to 1, the probability that y is equal to 1 is going to be k times 3 minus 1. Okay, k times 3 minus y. So here y will be 1. That's going to be 2k. So this is going to be 2k over here. And when y equals 2, okay, the probability that y equals 1 is defined again by the same expression here, which is k times 3 minus, but now instead of y equals 1, we're going to put y equals 2. So this is going to be 3 minus 2, which is 1. 1 times k is 1k. So that's 2k and that's 1k. And when y equals 3, then the probability that y equals 2, that should say, y equals 3 is going to be equal to, okay, when you put 3 into this expression here, so it's a different expression, k times, you're going to have 3 squared minus 8. So 3 squared is 9, 9 minus 8 is 1, so again it's going to be k. So this will also be k. And when y equals 4, we have the same expression. So the probability that y equals 4 is going to be k times, this is going to be 4 squared minus 8. Now 4 squared is 16. 16 minus 8 is 8. So it's 8k. So that's going to be 8k. And we can say the probability that y equals 5, we also use the same expression for 5. That's going to be k times 5 squared minus 8. 25 minus 8, which is 17, so that's going to be 17k. So there's going to be 17k. And then when y equals 6, it's just going to be k. And it says 0 otherwise. What does that mean? Well, it means that the probability of anything else is 0. It means that those are the only possibilities. 1, 2, 3, 4, 5, 6 are the only possible outcomes. Okay, anything else has a probability of 0, meaning it's impossible. So the only things that are possible are these outcomes. These are the discrete random variables from this experiment, which we don't know what it's about, but we are just, let me just make some space here. We don't know what the discrete random variable is about, so I just kind of imagine this is about a dice that is thrown, okay, and these are the probabilities of landing on those numbers. It's not a fair dice, it's a biased dice, so that's why they're not all equal. Okay, we want to find the value of k. Now what we should know is that the sum of all the probabilities, okay, is going to be equal to 1. The sum of all these probabilities is going to be equal to 1. So if I add up 2k plus k plus k plus 8k plus 17k plus k, that should all give me 1. So that's 2 plus 2, that's 4, 12, 29. 29 plus 1 is 30. That's 30k equals 1. Therefore, we can say k equals 1 over 30, and that's what we had to show. Okay, we didn't have to draw the table. We could have just taken these values here and just added them together. Okay, and then not forgetting the last one, the probability that y equals 6 is equal to k. And then we could have just said that they must add up to 30, to 1, sorry, and then we can say 30k equals 1, k equals 1 over 30. But drawing this table will also help us, I think, for other questions later on. It gives everything in an organized way, organized kind of format. So I'm going to actually copy this table. Maybe we'll need it later, so I'll copy it when we need it. Okay, now the next part of the question says find the exact value of the probability that y is between 1 and 4. So actually we would need this table now. So I'm going to take like a copy of it. Let's see if this will work. Okay, will it allow me to take the whole thing? Yes, it will. Good. All right, so now what I'm going to do is I'm actually going to put some values in here. So the 2, we know k is 1 over 30, so this is going to be 2 over 30. And I'll leave it in unsimplified form because I might have to add these together, and I'll have them all with the same denominator. So this is going to be k and k, that's 1 over 30 and 1 over 30. I can look from there. I can just get rid of these. So I know we have, for 4 it's 8 over 30, 8 times 1 over 30. For 5 it's 17 over 30. And for 6 it's 1 over 30. Okay, so I've now put the values of the probabilities according to the value of k that we found. Now we can start answering some questions. So for part B, it says find the probability that y is greater than 1 or less than or equal to 4. So greater than 1, we're going to start from 2. So for greater than 1, it's going to start from 2. So you're going to have 2, 3, and 4. So we want to find the probability, okay, that the random variable is equal to 2, plus the probability that the random variable is equal to 3, plus the probability that the random variable is equal to 4. Those would give us the answer. That's going to be 1 over 30, plus another 1 over 30, plus 8 over 30. That gives you 10 over 30. Okay, 10 over 30 divide by 10, you get 1/3. Right, that's the probability that y is between 1 and 4, not including 1, including 4, so 2, 3, and 4. So those added together. Then it says find EY. What does EY mean? It means the expected value of y, which is basically, it's the product of y with its probability for each of these, the sum of the products of y's, the y's with the probabilities of y's. Okay, so it's going to be basically, the expected value of y is going to be 1 times 2 over 30 plus 2 times 1 over 30 plus 3 times 1 over 30 plus 4 times 8 over 30 plus 5 times 17 over 30 plus 6 times 1 over 30. So the sum of all of those. So that's going to give me 2 over 30 plus another 2 over 30 plus 3 over 30 plus 4 eighths of 32 over 30 plus 5 times 17 is 85 over 30 plus 6 times 1 over 30 is 6 over 30. Okay, that's 50 plus 35, 85. That's correct. So you got 2 plus 2 is 4 plus 3 is 7. 7, that's 39. 39 plus 5 plus 6 is 45. 45 plus 85 is 130. So you have 130 over 30, which is 13 over 3. So the expected value of y is equal to 13 over 3. You can leave it like that. That's fine. Okay, so that's the expected value of y. That's part C done. And yeah, that's the answer to part C. I think that's done quite quickly there. All right, so that's the expected value of y. Now we're going to go on to the next question. We might need it. I'm pretty sure we will need it. So now the next part of the question says the random variable x, a different random variable, is equal to 15 minus 2y. Calculate the probability that y is greater than or equal to x. Now we have the probability function for, or the probability distribution for y. So what I would like to do is to rewrite this whole thing so it's in terms of just y. I know that x is equal to 15 minus 2y. So we can say that this is the same as saying find the probability that y is greater than or equal to 15 minus 2y. Okay, so we can rearrange this. We can add 2y to both sides. So that'll be the same as the probability of finding the probability that 3y is greater than or equal to 15. Adding 2y to both sides. And then we can say finally that that's the same as the probability that y is greater than or equal to, dividing by 3, 5. So finding this is the same as finding the probability that y is greater than or equal to 5, which is going to be the probability that y is equal to 5 plus the probability that y is equal to 6. So basically it's these two that we have to worry about there. And that gives us, for 5, it's 17 over 30. And for 6, it's 1 over 30. That gives you 18 over 30. Now 6 goes into both of those. 6 goes into 18. 18 divided by 6 is 3. And 30 divided by 6 is 5. So 3/5 is the answer. The probability that y is greater than or equal to x is equal to 3 over 5. You could say 0.6 if you want. And there's the answer to part D. And now we're going to go on to part E. Calculate the variance of x. Okay, now what I'll do is I'll take this. I'll borrow it and put it down here now. Now the variance of x. Okay, now what we can do from this table is we can find the variance of y. Okay, we know that the variance of, or we know that x is equal to 15 minus 2y. We know that. So we can link them together and then we'll deal with the variance part. So we know that x is equal to 5 or 15 minus 2y. X is equal to 15 minus 2y. We know that from the previous part of the question. I'll just write it over here. We know that x equals 15 minus 2y. So first I'll find the variance of y. The variance of y. Now the variance of y is equal to, now it's kind of like the mean of the squares, which is going to be y squared, like this. It's like the mean of the squares minus the square of the mean. So it's going to be like ey all squared. All right, so we already know what ey is. We found that in the last page. It was, what was it, 13 over 3? 30 over 3? 13 over 3. Okay, so we worked out what that is. That's 13 over 3. Okay, now we've got to find what this is. So what we've got to do is to find ey squared, we've got to take the y values and square them. That gives you 1, 4, 9, 16, 25, and 36. To find this then, to find what ey squared is, this part here, we have to take these squared values of y and multiply them by the probability. So you have 1 times 2 over 30 plus 4 times 1 over 30 plus 9 times 1 over 30 plus 16 times, what was that? Is that 8 over 30? Yeah. Times 8 over 30 plus 25 times 17 over 30 plus 36 times 1 over 30. Okay, so we're going to work out what these are. That's 2 over 30 plus 4 over 30 plus 9 over 30 plus 16 times 8, that's 80 plus 48, that's 128 over 30 plus 25 times 17, that's like 10 times 25 is going to be 250, and 7 times 25 is going to be 375, I think. Let me just put that on the calculator. 25 times 17, that's going to be 425, so you have 425, okay, over 30 plus 36 over 30. So now when we add all these together, we should get our answer, 4EY squared. So you're going to have 2 plus 4 plus 9 plus 128 plus 425 plus 36. That gives us 604 over 30. 604 over 30. Okay, if you just actually divide it, you get 302 over 15. 302 over 15. That's EY squared. So therefore, the variance of y is going to be 302 over 15 minus 13 over 3 all squared. So let's see what that gives us. Minus 13 over 3 brackets all squared. And that will give us our value, 61 over 45. 61 over 45. So the variance of y is equal to, does that give us something sensible? 1.35, 1.36. We can leave it to 1 as 1.36 is 3SF. We can leave it like 61 over 45 if you want. Okay, 61 over 45. If we need another calculation, I would use it in this form. So that's the variance of y. The question says, however, find the variance of x. So this is like this is a step in our way. Now I know that x is 15 minus 2y. We want to find the variance of x. Okay, and that's going to be the same as the variance of what x is equal to, which is 15 minus 2y. 15 minus 2y. So how do I relate the variance of 15 minus 2y when I know that the variance of y is equal to 61 over 45? Well, we can think of this as some sort of coding that has taken place on the values of x, right? Or of y, basically, of y. So if the variance of y uncoded is 61 over 45, the variance of 15 minus 2y is like you've added 15 to all the values. So for the variance, which is to do with the spread of the data, that won't affect it at all. So we can ignore the 15 part, but then you've multiplied it by minus 2. And because the variance is the square of the standard deviation, okay, because the variance is the square of the standard deviation, we've got to take that minus 2, we've got to square it, and we've got to multiply it by the variance of y, okay, and that will give us the correct scaling for this. So you're going to have minus 2 squared, which is 4, times 61 over 45, and so you take that and you whoops, what am I doing? 1 second. So you have 61 over 45 and you multiply that by 4, and that gives you 244 over 45, 244 over 45. So that is the variance of basically x. The variance of x is 244 over 45, which if you want to, you can round it, I guess, as 5.42 to 3SF. So there's the answer to part E of this question, which completes question number 5 from this paper. Other questions from this particular paper can be found in the playlist, which will be linked at the top of the page over here. Other questions from the topic of discrete random variables from the playlist, which is going to be linked over here, you can subscribe to my channel by clicking on this link. And over here, you will find a link to a video which tells you how to use my channel to find things that you might be looking for. Thank you for watching and see you soon.